Hello everyone, and I will share my screen. Hopefully my screen is visible, yeah, to all of you. And I'm audible too.
Yes, yes.
Thank you. Yeah, thank you. So this is kind of the last week's discussion, and so we will essentially see uh, the main things that have been discussed here. So the week 12 was on mostly on the ethical conduct of science, and so a good chapter to essentially finish the course. So the first thing we learn is about scientific ethics. So so ethics, as we know, are some kind of systematic norms that that are basically set up and is acceptable in a community. Yeah. So so we also have some scientific ethics. So like like in the course, they have mentioned some of them as honesty, uh, objectivity, and then integrity, carefulness, openness, respect for intellectual property, confidentiality, responsible publication, social responsibility, non-discrimination, competence, animal care, and human subjects protection. So these are some that has been discussed in the chapter. So I'm not going in detail anyway. Then we have some research misconduct. So there are some points that essentially are considered as research misconduct. Some of them are fabrication, distortion, plagiarism, breach of confidentiality, and interference. So you might have come across some case studies also regarding this misconducts in the chapter. Then one of them has been discussed in detail, kind of plagiarism. So kind of a common misconduct, and one of the things that we need to take care of. Uh, then another thing was maintenance of research data. So how to maintain it, and also maintenance of research data has to be done. So from personal experience also, you can see that if you have a good record of your research data, it's far easier to go back and repeat your experiments. And also, like, because in a day out day in, you go through a lot of iterations, like that start from your native experiment, yeah, whatever you started with, and you iterate a lot and then you get the data. So it's very hard to go back and also to repeat some of the things. So as a result, maintenance of research data is one of the important things in research. And also how you are ethically recording it is what discussed in the chapter. Then you have dissemination of research results, and one of the important part was how to assign academic authorship. Also, like in interdisciplinary research, like nowadays everything most of the research, I think so, like whatever you all are also going through is far interdisciplinary in nature, which involves uh, stakeholders from different departments and different expertise coming together and essentially helping in building a concept in the boundaries of that science. Yeah. Then there is openness in research. So we learned about how this research being open to all without any discrimination, being poor, rich, yeah, through some open access, how these open access journals are going through it, and how this being open and discussing your ideas in the scientific community helps us in getting far more creative research ideas. Yeah. Then there are copyright issues, unethical publishing practices are there. So and also it's kind of a clubbed ethics in publishing and unethical publishing practice. So there are some predatory journals, yeah, involved in it, and how they are operating here. Then we also discussed earlier. Also we discussed about citations and impact and all this impact factor and different uh, points, how they are like essential in uh, seeing how the paper is going, how the journal is doing, how the paper is doing. Yeah, we saw about this and discussed also the lure of easy publicity. And then something of very important concern is the environmental safety and experiment with living organisms. So this is something that might be ignored a lot, but this, like, whatever you do at at last, our lives is very important. Yeah, so we deal with, like, people who are with in a research laboratories, go through, are exposed to a lot of chemicals, uh, lot of equipments. Yeah, they can essentially harm you, and also the environment. So you have to be critical in saying that everything is okay, but your health or your safety is paramount. Yeah, you can't so there are always some guidelines how to do experiment safely, and also such that it doesn't affect the other uh, the environment, as in also lab mates, also the environment. Yeah, so going ahead, so I haven't kept a lot of theory here, just some discussion, because it was more or less, I think, was covered in the lectures. So yeah, so this is the first problem from the week 12, and after that we have some numericals, particularly from t test and chi-square test. So by that we will complete that one, and then, and the last, because I haven't taken week 5 because of on labs, so I will take week 5 and some questions on that. I believe propagation of error, yeah, and maybe yeah, propagation of error, and maybe the least square one. Maybe that two topics we can cover in the last one. I think that will do the things. Okay. So the questions can be multiple correct, single correct. So yeah. ACD, okay.
C. ACD is the
Okay. So okay. So yeah, please. You wanted to say? Okay. So the first one, A, yeah, using someone's work in its entirety without proper citation. So like, that is plagiarism, yeah. So using someone's work, so this will be there. Manipulating research data to achieve desired results. So is it? No, yeah. So what this thing has been given a name.
That is fabrication.
Yeah.
Data fabrication.
Yeah, fabrication. So this is a
Fabrication of
yeah, fabrication. Reorganizing the work of others without citing sources to present it, and so on. So it's kind of the The A option only. Yeah.
Falsification, yeah.
Copying different passages from various articles without appropriate, yeah, kind of same.
Yes.
So A, C, D. B is not there because it's data or like fabrication of data. So you have to tell which of the following is an incorrect description of falsification.
A is correct.
Okay, let's see others.
B.
Okay, let's see others.
C and D, sir.
Okay. Okay, so changing or deleting research data, results, or images is something is considered falsification. Yeah, we can't change the data or delete the data. So yeah, manipulating research results or equipment to verify one's own research hypothesis is also a form of falsification. Yeah, we are changing. It's similar to the A one. Yeah, we are manipulating and changing it. So this is also falsification. So adjusting values that did not reach the statistical significance to support the research hypothesis. So like to include the values in the in your statistical, like in the error bars. Yeah, so to include it is also a example of falsification. Entering and analyzing values at random to complete research before deadline. So you are essentially entering some values. So this also is an example of fabrication. You are fabricating new data. So this so essentially, okay, we have to cite the incorrect one here. So this will be the incorrect one.
Excuse me, is it a fabrication or distortion?
It's fabrication. Yeah, you are just so for example, you don't have a graph, okay, because you didn't have time, so you entered some data and analyzed the values and gave that graph.
Okay, that is fine. About the falsification is a fabrication or
Yeah.
in the question heading, falsification is used, isn't it?
Yeah,
So is it
falsification.
a fabrication or distortion? Exactly what it means.
So falsification is like falsification as we saw. Yeah, to basically to tell basically false results. It's kind of a distortion that we have discussed.
Or both.
Not both actually. Fabrication is essentially to make new data.
New data, okay. The last one is what you have mentioned here.
I think in case of fabrication, like you have a set of data, right? And in order to make it significantly correct, or in order to show a kind of a relationship, you just change the data, right? You don't change the value, but rather you change your data. For example, if you have in suppose 10 samples, and for 8 samples you have got a good correlation, good results, but the other 2 results are not according to the 8 previous 8 ones. So you accordingly change, like you make a 9 a 10 sample and 10 as a 9 sample, right? So then you get a very good correlation in that case. So this is called as fabrication. And in case of this distortion is like you don't have any data for it. Like as sir said, you don't have any data for it. You just have to represent certain data in order to get your research paper published, since they might have asked you. So in that case, you just put a.
I think you are misplacing the fabrication for distortion, distortion for fabrication.
So distortion as in distortion, like with word is it's like manipulation.
Fabrication is there is no data at all. We have not done the experiment. We have not run the machine. We have not given the medicine to the patient. We have not collected the data. We are just sitting in front of the computer or paper and pen. We are writing the data set.
Yeah, like
fabrication. Distortion is we have done the experiment, but we are only trimming or manipulating some of the aspects of it. Like
so like in fabrication, one of the important things is fake data. Yeah, you don't have fake.
It is completely fake data. We have not done any experiment.
Yeah.
But in distortion, we have done the experiment. We have got the values, but we are changing some values. We are modifying the values.
Yeah.
Or manipulating or something we are changing. If it is 5, we are making it 4.5. Or if extreme values are there in the data set, we are leaving it without being mentioned the causes for it. We are leaving out the extreme values of the data to get the significant results. Or we are
problem set, sir. Actually, falsification actually in this regard it gives an entirely different meaning, I think, because we've been taught about falsifying one the H0 and H1. So your H1, whatever the H1
No, that is falsifiable. So that is like
I'm getting confused with that falsification and I think it should be fabrication instead of falsification in the question.
Okay. Cool. Yeah.
Fabrication, it means it may be a question like fabrication, not falsification.
Yeah,
Okay. Sure.
Excuse me, sir.
Yep.
Is there any WhatsApp group for this entire set? I mean, who are connected lecture?
No, as such.
Actually, I go through previous video in their discussion that WhatsApp group is there. So
Okay.
I'm not in that group. That's why I'm asking.
I am not aware. Maybe yeah. I am also not aware actually. Yeah, others can answer. Maybe I don't know.
Anybody know? I mean, there is any WhatsApp group?
So here in this question you have to tell whom should you give. So you have to decide to whom to give authorship and whom to be mentioned in an acknowledgement.
The supervisor should be given the authorship here.
Okay.
Because in processing the research questions and methodology, the help has been taken.
Mm-hmm.
But the one who gives feedback on your methods and analysis, one of the faculty may not be given the authorship, but it should be acknowledged.
Mm-hmm.
And then lab mate helped with data collection and analysis. So he may be given the acknowledged, but even the roommate also may be acknowledged. But authorship,
Right, sir.
uh,
In case
authorship,
of LabMate, authorship can be given for data collection and analysis, because if a LabMate is carrying out the analysis, then it is I mean the authorship must be given, according to me.
Okay, so kind of this is open-ended question, like open-ended in a sense, it's a discussion question. So others can also put in their views. Anyway,
Actually, authorship can be given to the first one, and the one who helped in the data collection will get support. The rest of them will be.
okay. Others?
Supervisor and faculty member as well as lab mate. These three,
Given
yeah,
authorship.
yeah, authorship.
Okay. And the administrative member?
Acknowledgement.
Okay. So yeah, so like yeah, obviously it depends on the amount of the efforts to be given, but yeah. So essentially, as it is written that supervisor, yeah, the supervisor has helped a lot throughout the research progress and research question and methodology. So essentially, he should be considered as an author. And one of the faculty member gave helpful feedback on your methods and analysis. So this essentially happens when you go for when you have your meetings, yeah, your doctoral committee meetings and all. So they will have some feedback on your methods and analysis. But essentially, in most of the part, you acknowledge your acknowledge the committee members, yeah. So yeah, your lab mate help to data collection and analysis. So this essentially also depends on the like extent, yeah, like if it's like sufficient and it's like it is a sufficient one, and so he should be given a co-authorship maybe, yeah. But you being the first author, obviously, and he being a contributing author in that, because data collection and analysis is one important part of it. So nowadays in the papers you will have this in the last of it, in most of the papers they have this guideline to tell what all the authors have done. So in that, if you go down, you will have different roles that author can do. In that, data collection and analysis is also an important data collection and analysis is also a thing that can be given authorship. Your roommate, so who provides emotional support during stressful period of the research and who proofreads your paper can be given a acknowledgement. And as an administrative member, yeah, who logistically helps you, like conducting the meetings and everything, so he can also be given acknowledgement. So it's kind of the thing. So problem 4.
Option A.
Okay. Others?
For option A.
Yeah, so here it is salami slicing. So like in a situation where all things can be conducted in one whole study, you just piece slice it in different ones and uh, like increase the number of papers publications from it, and so that's what is salami slicing. So another, like, this is one misconduct, but in a sense it also degrades your the impact of the study, yeah, because if you have a whole study talking about all aspects of a phenomenon, its getting cited shall be higher. So you essentially like condense all the citations in one paper and increase it uh, in a flow, increase it like together, rather than like dividing it, which is a misconduct in a sense. So X is writing a literature review for her thesis and has been instructed by her guide to avoid plagiarism. Should the following measures X not should not take should X not take to avoid plagiarism?
Sir, can you please show previous slide?
Yeah, once maybe once we complete it, can we?
Okay.
Yeah. You want to take snap? Yeah.
Yes, sir.
Sure. Okay, no issue.
Will you upload this link, no, sir?
Yep, I will. I have started uploading in PDFs. I don't know. Think now the annotations are visible.
Sir, are you biomedical engineer?
Yeah, like
Yeah, I'm also. Actually, I have gone through your video, previous lecture. So,
okay. Yeah, like I am doing my PhD in biomedical.
yeah, I'm also doing this job.
Oh, nice. D. Okay. Yeah. So A, B, C. Okay. So writing concepts in our own words is something that can be taken. So acknowledge original sources. We need to original sources. We need to acknowledge original sources. We can take help from anti-plagiarism software. Yeah. So we have different softwares. We can take help from it, and then copying from her own previous work is something that essentially has to be avoided to to avoid plagiarism. Okay. Yeah. So yeah. So yeah, the C essentially is the correct one. So like it is interesting that negative findings in research should be published in a sense, because a lot of effort goes, yeah, towards doing experiment, designing experiment, and essentially this publication of negative findings is something that helps us understand, okay, this is some, if we go this path, some negative things, this hypothesis can be wrong. And so in a sense it helps us protecting the our energy and money and time to essentially go for research. So negative findings is an important part and something that should be acknowledged, should be promoted also, because yeah, a lot of negative findings usually come in our way. Okay, so the next part of questions are from t-test and chi-squares. So as you had told, so I think put around 5 or 6 questions maybe.
Sir, before going to this, I have one question regarding this box Whisker plot.
Okay.
Only one question I have. See, when we say outlier, just a minute, just give me a second.
Sure. Otherwise, we can also put it in the last ones also. No issue. Once we are.
I have one question from sir's book, which I didn't understood that concept. So, if you have sir book in front of you,
I have to, but yeah, like once we are just we have 5 or 6 questions, maybe then anyway we will have time. We have just finished.
Okay, I will take it at the last. No problem.
Sure.
No problem.
Yeah. Yeah. So our scientist could take only 9x measurements on the mass of a particle, and the measured values were this. The data provides sufficient evidence to say that the mass of the particle is less than 21.
Sir, I also have one question.
Okay.
In the last week in the week, I think week 6, there is a question in problem 5 that scientists could take only 10 measurements. And you solve the question by taking Z value.
Okay.
Why didn't we take T values?
Week 6.
Because there are only 10 measurements.
Okay, week 6, yeah?
Yes.
Okay, I don't remember.
Problem 5.
Problem 5, okay. Okay, I will see it.
That is scientists could take only 10 wala na measurement.
Yes.
No, ma'am, that is taken t-test only. I already did. Yeah.
And sir is solved by Z test.
No. He has done the t-test only.
T-test only he has done. I also remember.
Okay, मेरे सामने है.
Actually, I have notes also. Yesterday only I had gone through the video. That's why I have query from another also. That's why I said.
Yeah, I also take the printout.
So he had taken t-test only.
T-test. Okay.
Yeah.
Thank you. But here it is Z written. Thank you.
So the first steps would be to find, yeah, please.
The calculation of standard deviation, when to use n and when to use n minus 1 in denominator. Because in some cases, even with small number of sample size, we have used n. In some cases, they make the use of n minus 1 term.
Hello. I didn't hear. Hello. Yeah, can you repeat yourself? I didn't.
Standard deviation. The denominator, there is either n or n minus 1 depending on the number of samples. When to use n and when to use n minus 1, because in some cases they are using n minus 1 for
Okay.
Yeah. In some cases they are using n even for the less number of samples, below 10.
Yeah, got it. Okay. So essentially it depends on whether you are considering it as sample or whether you are considering it as a population. So I think in population we have to take it n. Hello. I don't know, your voice is too less, I think. No.
Sir, for the population it is n minus 1 or n? Because for the sample we take n. So how is it?
While finding the mean, we are using n, and whenever standard deviation is there, we have to apply n minus 1. That is the formula what we are using.
No. Sir.
And d of n we are finding, so we have to do n minus 1.
Well, is it to do with the population and the population mean and the mean? How is it?
Yeah, like here we have to take the sample standard deviation.
Yeah. No. But n minus 1, when the population is there, then we take n minus 1, right?
No. When we have population, we have n, and when we have sample, we have n minus 1.
Okay.
Excuse me.
Yeah.
So what you have discussed, n minus 1 or n for population and for samples?
Yeah, so please. For population we take n, and for samples we take n minus 1.
For calculation of what?
Standard deviation.
Standard deviation of the mean, standard deviation of the sample, and standard deviation of the mean population.
Yeah.
But to calculate the standard deviation of the population, we have to calculate the standard deviation of the sample first.
Yeah. So here
calculation of the standard deviation of the
here first things
sample,
here
we have to use the n minus 1 only.
Yeah. First here you have to calculate two things. Yeah, the sample mean and the sample
yes,
standard deviation. Yeah.
standard deviation.
Yeah, these are the first things that
Even for population also, first we have to calculate the standard deviation of the sample itself.
Yeah.
Then we have to convert it into standard deviation of the means of a population. That is standard deviation by square root of n.
Square root of
different
n.
formula.
Yeah.
So the answer to it is like the data does not provide a sufficient evidence.
Okay, so what so maybe we can go step by step, yeah?
Step by step, alright. So the mean that I have found is 18.86.
18.86.
86. Standard deviation is 2.258.
2.25. Sample.
Standard error is
So you have taken n minus 1, yeah?
Yes, I have taken n minus 1.
Okay. Okay. Okay.
Standard
Let's see
error
others.
has
Others are doing it in the same way. Okay. Then what you did?
Standard error that I have found is 0.7527.
Okay. How did you find?
Standard deviation divided by square root of n, that is 9.
Okay. So 2.258 divided by root 9.
Square root of 9, yes.
Okay.
This has come out to be 0.7527.
0.7527.
7.
17.
Yes. Then
27.
I've taken since the
Okay.
27, yes. Then degree of freedom, so I've taken here t-test. So degree of freedom is 8, and for 0.01 or significance level, the value is 2.896
So, okay.
in t-table, which is greater than 0.7527.
Okay. How did you
After that,
find
I
t?
have a confusion.
Value of t?
For 0.01% significance level.
Yeah.
1%, yes.
Like the t
So
value.
directly
First
from
you
the
have to
t
calculate
table.
the t value, yeah?
We need to
T
calculate
value has to be calculated no, first.
Yes.
Minus
We
mu.
have to calculate the t value.
Mm.
We have to calculate t value.
Yeah.
That is x minus x bar divided by standard error.
Yeah. So x minus.
Is 18.86 divided by 0.7527
Now 18.86 minus 21.
minus 21 divided by standard error.
All right. So this t is coming out to be 2.843.
2.843.
Now from t table for 0.01 significance level, the value is 2.896.
2 point.
Calculated value is less.
Less.
Yes. So our calculated value is less.
So let's check. Okay, others you keep doing. I will check the table maybe. Zero point 0.01 and what is the degree of freedom? 8. For me it's telling 3.355.
All right, sir. So here I also have one confusion. Like in T table, they have given one tail and two tails, right?
Yeah.
We always have to. Okay, so we always have to consider the two tail value, significance values.
Yeah. So like
Okay.
yeah. It also depends on how you are saying, like how you are like what the question basically asks you. So in a sense, if so you have to understand what's the significance of one tail and two tailed. So if you know those, then it's okay. Then you can do. So like I'm not going into too much technicalities, but one tail test is something when you have a direction, yeah. So you have value A, is it greater than B or not? When you have to compare these things, then you have to go for one tail test. And then you have two tail test when you have to say that the means of two things are same or not. Is it coming same or not, like this when we are comparing two values. Then you go for two tail test. So like I don't know if it will consider the whole array of the questions, but this is the so approach that you can see. and others maybe you can read about it when you should approach two-tailed and one-tailed. But this is the thing that I follow mostly, and it essentially sits in most of the conditions.
So in this example, like even if we go for one tail or two tail, our value is t value is coming out to be greater from table, and the calculated value is less. So is it enough to say like the evidence that has been provided, the particle of the mass is less than 21 is correct?
Just let me see.
Sir, it is given, do the data provide sufficient evidence to say that the mass of the particle is less than 21? So in this regard,
in this case, I guess yes.
Yeah. So, what?
So what is the table value?
Yeah, the table value is what?
3.355.
So in this, essentially, if as the values are as the obtained value is less than the table value, we can say that
null hypothesis is accepted.
Null hypothesis is accepted, and yeah.
so
This is the alternate hypothesis. That is given problem.
Huh?
This is the alternate hypothesis.
I'm not able to hear actually. I don't know.
he is telling the alternate hypothesis is rejected.
Yeah. So so that's kind of the basic one, how you do it. So but you can see how you are, so that was a nice point, how to decide on when you have to do one tail test and two tail test. So should we go ahead?
This we are considering the one tail, so
No, this we have to consider the two tailed here.
two tails.
And it's I don't know, because this is not a statistics course, so how they are considering these tails, one tail and two tail is something that is interesting to see, like, because there's a concept behind it, okay, how they're considering the tail. So essentially the tails are, so these are the tails, these are the tail portions. So if you are considering two tail, they are considering two tails, these two tails, and basically the two ending points. But when you are considering the what do you say, one tail, it is not considering this one, maybe only this one tail. So it has a basically statistical, we don't go in details because this essentially is not a statistical course, but you all can see how the things go about it. So that's the funda behind this one tail.
What I know about two tail and one tail test is, so we calculate the values for only one side. We are not going for negative, or we are not only going for positive. Only one side we are calculating. Then if you want to fix a significance level, one tail test.
Okay.
Usually 5% significance level we test, isn't it? 0.05. 90, that is for the
95%
confidence levels, we 0.01 significance. That is 1%. So then for single tail test, you have to consider it as 10% significance level, as we set 5% significance level for two tails. So when we get a value for 10% significance level, like here, we get 2.843 is the value. That is for 0.01 significance level. If you calculate it for single tail, then you get a value as 2.843. Then you have to divide it by 2 for two tail test. Then it will become something like 1.423, something like that. It is 2.5% one side, 2.5% one side. That's
the thing I was telling. So So that basically the significance gets divided into two tails. That's what we are trying to say.
We are single tail test means either we are neglecting the positive side or we are neglecting the negative side. We are calculating only for one side, so that both the sides will be merged, so that significance level has to be increased. So if you are calculating for 5% significance level in two tail test, you have to test it for 10% significance level in one tail test. That's what I have understood.
Yeah, like the thing is, like you told, yeah, the basically if we are testing for like for example the 0.5, yeah, p value, so we will consider 0.25 here and 0.25 here.
Yes.
Yeah, so yeah.
That is for one tail test.
So yeah, that's what it is. So yeah, maybe the books will tell you better in a way. Should we go ahead?
Yes, sir.
Yeah, sure.
So the answer is no.
Yeah, no. Like alternative hypothesis is rejected. So here two the two hypotheses, yeah. So like to extend it kind of. H naught means there is no effect kind of. Like eating fish does not help. Increase IQ. Yep. Yeah. Bhola, you can unmute and tell. Yeah. You want to tell anything? Ask anything? Okay. Maybe by mistake.
-1.
Huh?
Here also we consider n-1 for calculating the standard deviation.
I could not hear you. Can you repeat?
I am saying here also we will consider n-1 for calculating standard deviation.
Yeah.
Yeah, thank you.
Sir, in case the null hypothesis is found to be correct.
Okay. So so maybe we go with the same thing, yeah? Last time what we did.
Yes, sure.
What's the sample mean?
106.
Okay. 106. And sample
standard deviation is 8.83.
Okay. 8.83 standard deviation.
Error is coming out to be 2.55.
Standard error 2.55. 0.55. Okay. Basically, how you calculated this? Standard deviation.
8.83 divided by square root of 12.
Square root of 12.
8.549.
What is it?
8.549.
8.549.
Yeah.
Okay.
Sorry. You are asking
Standard error is 2.55.
Okay.
That is 2.55.
Yes.
Actually, it comes around 2.549. Yeah.
So the calculated t value is 2.352.
How you calculated?
So here the mean value is given like 100 or more than 100. So 100 minus 100, 106 divided by 2.55.
Correct?
Yes.
Then it is 6 by...
this is 2.352.
Okay.
And from table with 0.05 significance level, for two tail the value is 2.201.
Degree of freedom is 11.
Degree of freedom is
11, yes. Or degree of freedom is 11, yes.
Yes.
So this is two-tailed or one-tailed test?
I have taken two-tailed this time.
Okay, why?
I think we can even go for sorry. We can even go for one tail by dividing this t value, calculated t value by 2. And I don't know.
So this is an example of one-tailed test actually.
Sir, how do we decide that it is a one-tailed
so
test?
Yes, exactly. How can we decide this?
Yeah, so when you have your hypothesis and you have to compare the values in one direction, whether it is equal and greater than that value, you go for one-tailed test. That's the concept, because you have only considered one tail and then you consider whether in this direction it is more or not. But when you are comparing two means and telling that whether the two means are together, like are the two means similar or are they statistically together or statistically equally, then we go for two-tailed test.
It is on the question asked, because here I didn't get. Can you repeat?
Sir, if as per my understanding, there is two mean we have to find, so we can go through the two-tailed test, right? And if there is one mean only, so we can go through the one t-test. I mean one tail.
Like if you have to compare that both of the means are equal or not, then we go for two-tailed test.
Okay. That
and if you have to tell that the one of the mean is bigger or not, or is smaller than that or not, we go for one-tailed test.
One tail. Okay.
So there
We
is
need for finding the value, one tail test. To test the hypothesis, two tail test.
Yeah, like the concept is that, like if you have one-tailed test and finding out, like when the direction, when there is some direction component involved, is it bigger or less, then you have one-tailed test. Direction is involved here.
Sir, can I ask you one question?
Please.
Sir, if we have three variables and according to me, I am trying to use a two-tail, but they are suggested me one tail is also sufficient to identify the solution. Is it true that?
Like we have to see the question maybe.
Yeah.
So okay, yeah, Shubhajit, yeah, please. Okay. So so what is the table value here? So essentially, if you are seeing the table value
1.796.
so if you have a two-tailed table value, so whatever table value you will see for I think what's the p value? Okay, I haven't mentioned p value. You can take 95%, like 0.05 maybe. So whatever in two-tailed test, whatever p value will have 0.05, you have to see for the 10% actually. What it is coming? 1.796.
Yes.
Okay. So
So for significant level, we have to take 0.05, right? While seeing t table.
It depends on the t table actually. If you have a single test t table, then you can directly see.
Here is not mentioned, so we can take 0.05.
Okay, then maybe it's for that, like normally it's two-tailed test that if it's not mentioned, then maybe most probably you will have a two-tailed test table.
So this is the value that I've told, this is for one tail, alright?
Yeah, this is for one tail, yeah. So I think I think you have taken from a one-tailed table. Yeah.
And for two tail, it is 2.20.
Yeah, that will be different. But if you have a two tail table, and if you see the significant the table value for 0.1, what is it? It should be 1.796.
So as per 0.05, as you told that we have to take a 10%, right? So according to it, it's one till 1.796. If we are going to take, so it will be
Now, like if you have a two tail table,
okay.
then whatever the p value is there, if you have a two table t table, two tail t table, oh my god, and then you have to see the double of it. So you have to see 0.1 in a two tail table. It should be 1.796.
Here p value had not mentioned. We had taken.
I think I just missed it out. Yeah.
So in exam, if there is no p value, so we are taking for one tail 10%.
Yeah.
And two tail is for then we can take 5%.
Yeah. I missed it somewhere. That's why.
Okay.
So 1.796, and we have value of 2.35. So what we can tell?
Null hypothesis can be rejected.
Null hypothesis can be rejected. So null hypothesis is rejected because the obtained value is more than the table value. Yeah. Should we go ahead?
Yes, sir, we can.
Yeah, sure. So this is a question of double group, yeah, two groups. So what you have to test is that this is the H naught, and H is When is the exam? When is your exam, as in?
13th Sunday.
29th, 30th.
Huh?
30 Sunday.
13th April.
13? 30 April.
30
Okay.
April.
Okay. So the next session is there any time to conduct? I don't know. Next Sunday will be 30, yeah. Next okay. So okay, then conducting the next session should be before the first half. Okay, then I will try to prepone the next session. Yeah, maybe yeah, Monday or Tuesday. Maybe that will give. Otherwise, Sunday is no use.
Sir, we have one more exam on 29th.
Okay, so I will try to take it tomorrow. It's very hard because I don't know. I will mail NPTEL and they will. I don't know. But yeah, Tuesday or Wednesday maybe. I don't know. Wednesday they allow or not. But, yeah. But will it be okay for all of you? Okay.
So Z value for 95% is 1.65, 1.96.
Now this also is a t-test question.
Okay, 25 questions.
So in this case, our null hypothesis is that the herb does not reduce the diastolic blood pressure, right?
Yeah, like this is the hypothesis. Yeah, that experimental and control is same, means are same, and experimental and means are not equally is alternate.
So what is the table value?
Table value
2.069.
table
So
value.
calculated value is coming out to be less than.
Okay, so how you did it?
So difference between the sample means like difference between the means experimental group mean and to that of the control group mean divided by the standard
Estimated error.
which is the square root of sigma square by NE experimental group plus to that of the control group sigma square C upon NC.
Whole square, yeah. Yeah.
It is not root.
It's only the square of this.
So numerator is square, but denominator is not in square. Like the denominator in the denominator.
Yeah. Okay. But it will come. This will.
Error is 1.1532.
This root will go upon this. Because of the root square, it will go.
The same. Yeah.
Yes, sir. Yes. Sir.
So and degree of freedom.
23.
How?
Like 12 minus 1 plus 13 minus 1.
Plus 13 minus 1. Okay, so here how it is coming? 81 minus 83
divided.
Standard error is 1.15.
1.148.
My value is 1.152.
Okay, like what I have to write? 2.3, yeah? Square by 12. Yeah, and 4 square by 13. What it is coming?
1.742. The total T value, calculated T value.
Okay.
Yes, sir. Mine is coming 1.736.
Okay. I haven't calculated. So, null hypothesis cannot be rejected, yeah? Yes?
Yes, sir.
Okay. So, null cannot be rejected. Should we go ahead? Yes.
So the conclusion, please explain nice.
Yeah, so the calculated value is 1.742. I think so. I haven't calculated it. And it is, so we have to now compare the calculated value to the table value. So if the table value is more than the calculated value, then we have to, then we can reject the null hypothesis. And if it is more, what it is? Sorry. Then we have to accept the null hypothesis, and basically we have written that null hypothesis cannot be rejected. And then if it is more than the table value, we have to reject the null hypothesis. That's the thing. So basically we have two values now. One is we got from our calculation. One we got from the table. We have to compare both the values. Depending on whichever is bigger than the other, we have to conclude the thing. Yeah, makes sense.
Yes, sir.
Okay, should you go ahead? Okay, so this is a chi-square test question, I believe. Yeah. So a die is suspected of being biased. It is rolled 24 times with frequencies shown below in the third column of the table below. And conduct a significance test to see if it is biased. So, like in a die, yeah, we have a probability that every number should be coming, like have a same probability of appearing. Yeah. So, but here when they have like tested it, they saw that 1 has come 8 times, 2 has come 4 times, and whatever it is. So you have to tell whether the die is biased or not.
So this table is given table, right?
Which one?
The table is given, right?
The table is given, yeah. So in some conditions this table may not be given. So yeah, in questions this may or this may not be. Then you have to think, okay, yeah, there's the probability thing here. But yeah, this may or may not be given, but here it is given. So you can see at 5%.
So can you explain this question in bit?
Also,
yeah, once at a time. Yeah, I didn't hear both of you actually.
They're asking you to explain the question.
Okay. Yeah.
So I was asking that if you can explain this question step by step, because I'm unable to solve the questions regarding chi-square.
Yeah, sure. So basically you have a die and you have to check it if it is a biased die or not. So what you will do is you have to roll it 24. So basically the tester is rolling it 24 times and noting the outcomes down. Okay, so the possible outcomes are 1, 2, 3, 4, 5, 6. Yeah, and so basically whatever times it comes 1, he will tally it. Yeah. So upon rolling it 24 times, he saw that the observed values, the 1 has appeared 8 times, 2 has appeared 4 times, 3 has appeared 1 time, 4 has appeared 8 times, 5 has appeared 3, and 6 has not appeared. But in an ideal condition, 24. So you can basically divide 24 with the 6 outcomes and take like 1 should appear 4, 2 should appear 4 times, 3 should appear 4 times, and 5, and the list goes on. Yeah, like we assume that everything should appear in 24 when you appear as 24. So it should be as like to be equally probable, because we are considering that. That's what the question says. So this is the observed and this is the expected values. So yeah, so you need more on this, like clarification on this.
So the solving part of this question.
Okay. Sure. So yeah, I will just writing the 5% significance here. 5% significance. Okay. So first maybe starting with the formula of chi-square. Yeah, chi-square is summation of the observed minus square by, yeah, this is the basically the, yeah. Somebody is trying to speak. I don't know, my volume is less. Yeah, you want to tell anything? Okay, so this is the thing that we need to calculate. Yeah, so we need this value and this value. Okay, so yeah, so we can extend the table and also calculate O minus E and then also O minus E whole square. Yeah, so O minus E is 4 0 minus 3 4.
So in the question where the expected values are given, then we have to calculate by using the formula, like in the denominator we have to write the standard error of the mean whole square. So in the class also we have seen that in the videos also, the chi-square test for comparing measurement with some expected value.
Yeah.
The case where the expected values are given and the corresponding standard error are given.
Okay. No, that is so that is a different group actually. So we have different groups, yeah. Chi-square test for categories. Then we have chi-square test for what is comparing measurements with expected values.
So in the question like then where we have given like expected values are given.
No, it's not like it is given or not. Like here it may not be given, yeah. Then but you from your native knowledge know that a die has equal probability of every number to be appearing.
Yes.
So yeah. And minus 1 4 and then we have to square it. 16 0 9 16 1 and 16. So the sum is, can anybody calculate the sum? Sixteen is 48. 58. Yeah.
58.
So what will be the answer?
14.5.
Huh?
Chi-square is 14.5.
No, sir. We need to add another column here.
Divided by E.
That is observed minus expected square divided by E.
Yeah.
That is 16 by 4. 16 by 4 for everything.
There is a sum overall, no? Like
Overall chi-square.
Overall it is, yeah, so just directly we
calculate
can.
independently, like for one observation, for one outcome.
Yeah, like I am taking because the observation values is same, so the expected value is same for everyone. So
chi-square is coming out to be 14.5.
yeah, it's 14.5 because the denominator is same. Yeah.
I didn't get you. Can you explain?
So it's like so the thing is 16 square by 4 and 0 square by 4 and 9 square by 4 and then we can write everything as 16 square plus 0 square by 4. That's what I've written.
Okay. Sir, how the expected value 4 is calculated?
4 is calculated in a sense. So you have a die, you throw it 24 times. So you have you have 6 outcomes, and you are dividing it 24 times. So 24 by 6 is 4. So everything should appear 4 times. That's how we got expected value of 4. So the table value, so okay, the first thing will be the
Sir, when expected value is not given, so we have to find, right?
Degree of freedom.
yeah.
As in assignment, that kind of question asked in past.
Yeah, so like here, if it was not given, you had to find it. Yeah, like
Somewhere it is table is given, some places it is not given.
Yeah.
Wherever not given, then we have to calculate it.
calculate it, yeah.
Based on the question.
Yeah, true.
Degree of freedom is equals to R minus
Degree is 5.
E minus 1. Row
Yeah.
minus 1.
Column minus 1, row minus 1.
Yeah. Into row minus 1. Minus.
So what's the table value?
Two 2.571. 571.
Okay.
For
So
chi-square,
chi-square. I didn't check the table though.
it is 32.007 for 10%.
Chi-square is different.
Yes.
Different.
Sir, here also we need to see the significance level or
Yeah. 95%.
95, it is 35.172.
Sir, chi-square tabulated is coming out to be 11.070.
Okay, let me see it.
Degree of freedom is 23.
Degree
No.
of freedom
5.
is 5.
5.
11.070.
Yeah, it is 11 point.
11.70.
0.070.
11.070.
Okay.
70.
Excuse me, sir.
Yeah.
So here we are taking degree of freedom as 5 or 6, sir?
5.
Please explain how it is myself.
So we have there are 6 outcomes. We are n minus 1 we will take.
So we have to calculate on the formula that C minus 1 into R minus 1. C is column, number of columns, and number of rows. So rows here are 6. So rows minus 1, 6 minus 1 into
columns is
that is
2.
2 columns are there. So that is C minus 1, that is 2 minus 1 into 6 minus 1.
Yeah.
It comes out to be 5 into 1
5.
is 5.
So what's the conclusion? So null hypothesis was that Dias is biased and Di not biased, unbiased maybe.
But usually the null hypothesis talks about the equality.
You said here conduct significance tests to see it is biased. So
yeah, like the expected values and the observed values are equal. That is null hypothesis. So observed and expected values are similar means it is not biased.
Come again.
When expected values and observational values are same, means there is no difference. Because the null hypothesis always talks about the equality, no difference. So expected and observed values are same. If observed and expected values are same, means it is not biased. H0 is not biased. Okay. So H1 is, they are biased.
Is it others are getting it?
Yes, sir, because in previous sessions also they have said that when we talk about the equality, then null hypothesis always talks about the equality. There is no difference in the observed or experimental value, for an example. In case of null hypothesis, whereas alternative hypothesis, like if you see some differences in calculation or in your result, then
okay. So basically here as both the values should be equal, so this should be unbiased.
Yes, the null hypothesis is Dias is not biased.
Okay. Yes. Okay. So we can tell that
yes, our final answer is that the Dias is not biased since calculated value is greater than table value.
Okay. Should we move ahead?
Sir, how much value?
I didn't get to. Their voice got cut.
Sir, how much is the table value?
11.070.
So against this degree of freedom, what is the significance level which is taken to get this 11.070?
95%.
So can you repeat the final conclusion, sir?
Yeah. So we so as the table value is less than the calculated value, so we can say that null hypothesis is rejected.
Okay.
And even here, if the degree of confidence is not given, should we take it as 95%, sir? At any point of the
Yeah,
mentioned in the question?
yeah, mostly you can take, I think, yeah. But yeah, in a sense, they should give it, but yeah, if it's on safe side, it's you can take it. Should you go ahead? Okay. Uh, are you telling me or?
We need to calculate the expected value.
Hmm?
We need to calculate the expected value.
Yeah.
That is the comparison to the no drug.
No drug, yeah.
Is it right?
Yeah, correct.
Or first sale,
Yeah, please.
out of 200, 120 were cured. So out of 300, how many will be cured? This for drug.
Mm-hmm. Were you asking me something? So here, basically,
Yeah.
yeah. So there are two groups. One group is they have given new drug, and other is not giving. So out of this drug, 300 people are giving this drug, in which 200 are being cured, 40 condition worsened, and 60 is no effect. Similarly, in the no drug, 200 people were given, in which 120 were cured, 30 conditions um, worsened, and 50 no effect.
So in this question,
Mm-hmm.
how this expected value is calculated?
Okay. So others can also help.
Yeah, even I wanted to know because I didn't understood the last problem which was there in the textbook. Find it difficult
Oh,
to.
okay, okay, okay. The one I think is similar, yeah. The vaccine one, I think so.
Correct.
Okay.
Even in the main class, there was a question related to IQ. IQ question was there, and that also expected value was calculated. But how it was done, I was unable to understand.
Okay, sure. So yeah, then we will. I actually have solved and put it in the the photo. I thought I won't be able to finish it in time, but yeah. So uh, yeah. So uh, uh, yeah. I think this is the expected one. And, this is the observed. So no, no, no. So you have expected frequency of for any cell is the row total into the column total by the grand total. So the row total, yeah. Uh, row total is 300. Keyword is 320 by 500. The total one. We are getting the expected frequency for any cell.
Sir, here no drug means placebo.
Placebo, yeah.
So
Control.
in the previous question, what we have taught first of all, we have to calculate the probability. Through that, we have calculated expected value.
Yeah.
That procedure is also correct.
Yeah. Like the last question was on this.
Like
Yeah.
in the assignment, sir. Like
Oh, okay, okay, okay.
we have given drug A and drug B, and we have given placebo also. So here in that question, we have solved
Yeah, yeah,
by
yeah.
calculating the probability of like in a placebo, like if there is no effect,
Mm-hmm.
if we apply the placebo, then we have to calculate probability of through placebo, like
Yeah, like probability in a sense, it's the same. Yeah, how what is the it is essentially coming to the ratio, and then you are calculating the value from there.
So, sir, if we're going to solve this question, the previous question which we are given in the assignment, by through this method, like row total multiplied column total divided by grand total, the answer of chi-square calculate is coming out to be different.
Like here the question maybe is not the dicto one. Yeah, that may be a case. You can't put so it's not a formula actually. Just how we are getting the value, not a formula.
So that question can we apply the same procedure for calculating the expected value?
There also I think we add some we have some mathematical.
Correct, we add that. This same formula we have used there.
Okay. Yeah, like the formula is this is not a formula actually. Like this is a kind of proportion. Yeah, what proportion of that is?
The same has been used there, and then we derived.
Yes, sir. The procedure we just follow for this question, we have just follow the same procedure for that question given in the assignment also. But our answer is coming out to be the chi-square value, calculated value is coming out to be different.
Okay. But then you have that solution, yeah? That solution says is otherwise, yeah?
Yes, sir. The solution, the procedure for what we get in the solution is quite different. There also, we first of all calculate the probability and then we have to multiply by.
In actually, placebo is given, so the method is different. If placebo is not given, then method is different. Like that way, previous lecture had this discussion also.
So here, means it's a kind of placebo, no?
Yeah.
Yeah.
That is placebo. So we have to, as you previously told, na, that we have to calculate the probability. That is correct.
Yes.
We have to do, and then we procedure as we did in previous question. That we have to solve that given the formula and solve this equation. And we have to find the expected value. Expected value as sir given the formula, na, row total and column total way, that way. So I got 192, 42 for the no drug in the no, and for the drug expected value. Regarding to cured, it will be 192 expected value, and the condition that is 42. And this time calculating for the no effect.
Sir, can we attempt this question?
Yeah. So then we have this. Yeah, I've just put it. Then we compute the chi-square, and the degree of freedom was coming to be 2, and the table value at this one was 5.99. So since the value is less than the given tabulated value, the effect of the drug is not significant and null hypothesis is accepted. So this I thought I will not be able to complete actually, so I thought I will just put it and solve it here.
This is right, sir, as I did half of them, so it's correct. Like 192, 120, 47 as I have given expected value.
Okay. So that was all of it I had.
Sir, I had one question.
Yeah. So you can have questions. How to put new slide?
Can you please share? I have some questions to all of you. Is there any WhatsApp group?
Sir?
Krishna ma'am, is there any WhatsApp group?
No, I don't know.
Okay.
Yeah, please.
So can you please share all the answers for all these problems what was solved today? The solved answers if you can share on the slides and the web.
I will eventually anyway upload the PDF, annotated PDF. So can you get access? Can access it from there?
Yeah, we are getting it now. Earlier it don't used to be there, the annotated one, but now it is there.
So if it's okay, can you like obtain it from there?
Yes, sir. The previous one it was written, no, sir. So if you calculate the last part was very clear, we could understand. Okay, so what you had solved using the formulas and all. So the similar way, if all the formulas are, all the problems are solved in a similar way, it will be very easy. Sir. Because sometimes it will be overwritten and it's a little confusing for people who are not the scientific, the mathematical field.
Got it.
Sir, I had this question on box whisker plot. Hello?
Yeah. Please tell.
Yeah. So one of the questions which is there in the book,
Okay.
Are you able to see the book with you or not? Because
Are you like presenting it in a sense? Because I don't.
No, I don't have. I was referring the book and I was trying to solve it, but I had only one confusion there. For this box whisker plot, the value starts from right from 10.1 till 20. Okay, wherein Q1 is 15.6, Q2 is 17.
20.
10.1 to 20.2.
Okay.
Yeah, this is the range. In that, Q1 is 15.6. Q2 is 17.2. And Q3 is 18.7. So in this, when we calculate IQR from this, the IQR is 3.1.
Okay.
So when we calculate the higher whisker data point, so it comes out to be 23.35.
Higher whisker point means?
Like going over Q3, the one which is like when
maximum acceptable region.
Q3 plus the formula. Sorry?
Maximum value.
Maximum acceptable range.
Maximum acceptable.
This one?
Yeah, this is one. This is the one.
So 15.6 plus 1.5 into 3.1 something.
Yeah, 3.1. So it comes out to be 23.35.
Okay.
And for the last data point on the whisker plot, it comes out to be 10.95, like Q1 minus 1.5 IQR.
This is coming 10.95.
10.95.
Okay.
So my question is like whether we should consider 10.95 as outlier or we should not consider in this which is an outlier, because you got the range, 10.1 till 20.2. So I was very much confused. Here it is written, therefore for the last point of the whisker data plot, it is written, therefore we suspect that this point is an outlier and the set end of the whisker at the last data point about 10.95.
So 10.1 is the outlier because our range is up to 10.95. So the value 10.1 is below that range.
Yes.
Sir, but here it is written like that 10.95 is the outlier basically.
See, 10 point. So the thing is, depends. If 10.95 is part of the set, Is
Yes,
10
it is a
point...
part of the set.
No.
I don't know because I don't have that set.
No. Our data points are, I'll just tell you, 10.1, 15, 15.3, 15.9. So 10.1 is the part of the data set.
Okay, yeah.
So 10.1 is the outlier.
So yeah.
No, actually, in this question, the 10.1 value is an outlier because just see the scale. When you look at the scaling, so 10.1 comes a bit earlier, and 10.5 comes 10.95 value, our Q1 calculated value, that comes later. So since this value, the same question, the same confusion I also had before attending the previous session, but this doubt was cleared in that session itself. I was also thinking that since 10.95 value is greater, then why should
But
we?
in the book it is written that 10.95 is an outlier.
No, then it might be a misprint then, because we have calculated this 10.95 value. It is not given anywhere.
Yeah, whether I am interpreting this sentence is wrong. See, it is given that going below the lowest point of the box, okay, which gives 10.95, we see that there is one data point below the value. Therefore, we can suspect that this point is an outlier and the set of the end of the whisker plot at the last data point is about 10.95. So,
What is the data next to 10.1?
So exactly what it is saying, na? The data next to 10.95, that is 10.1 is an outlier.
Yeah, so anything that is in this region is outlier.
Okay.
You can have 10.1, you can have the other, if the set has other values of the 10.3, 10.8.
So what about, sir, what about then 23.35? Because 23.35 value is again beyond 20, which is our highest.
So this side we don't have any outlier.
23.35, that is a calculated Q3 value. Okay.
Yes.
So anything which is coming below to the calculated quartile values, that can be considered for that data can be considered, whereas the one which are beyond that, yes, that will be the outlier.
It is the range.
Sir, if the value...
Since the calculated value is 23 and our set value is 20, data set value is 20.2. So it is, that is not an outlier.
Yes, it is come in the range.
Sir, if the minimum acceptable range is 10.95 and if in the data set the value is same, given 10.95 after the first value 10.1, then what will be how will you consider outlier in that case?
So 10.95
in
is
that case,
acceptable, I think.
I guess in that case 10.95 will be considered within the data, whereas the
less than that
other
is
value
not acceptable.
So, sir, here 10.1 is an outlier. Right?
Yes.
Yeah.
Because
so if the data set had anything that is less than 10.95, it would be an outlier. And the outlier is something that is on the data, not on our calculation. So if our data had 10.95, then you can consider it, like you can consider it in a question.
Here 23.35 on a higher side we are getting a calculated value which is higher, but on the data point it is lower only, so we don't have any outlier there.
Yeah, like you have to see it in the number line kind of.
Like on the box whisker plot which we will make based on the Q3Q. So our last data point here is 20.2, right?
20.2, as you have told.
That is the highest data point. So because our calculated value is higher, so we don't have any outlier.
Yeah, so you have a range, so you have to lie in that limits. Those are the limit. Anything out of limit is outlier.
Okay.
And so in that condition, the acceptable data will be the next one that is bigger than 10.95. Anything that is bigger than 10.95 will be considered the acceptable data, because anyway 10.95 is not in your set. Anything that will be
not in our set.
Anything that will be larger than that, for example like 11, 12 or something, it would be the next one will be the accepted one. Yeah.
Okay, but it is when it is asked for a outlier, then anything out of that range, whatever is coming, is an outlier on the data scale.
True,
Data point.
true.
Yeah. Okay. Okay. Thank you. Now my doubt is clear.
Excuse me, sir.
Sure. Yeah, tell, please.
Actually, yeah, so in week 6 assignment, I mean video, your lecture, problem number 4 had solved regarding to assignment 6 related questions. So there is confidence level. Can you state the actual value lies in the range 5 ppm to 5.036 ppm? Question was like that. So when we are finding the CL, so equation is range minus x bar upon s, right? So whatever the ppm had been given, and we have to subtract that mean value, okay, and divide with the standard error. Yeah, so I had get the negative y value 0.59, and in that slide it has mentioned 0.57, that is positive.
Okay. Okay, so you have find the
In this question, I also have one doubt. You said for minus 0.5, it is 0.2843, and for positive value, you multiplied it by 2. Okay, Z table says for negative values of Z it is different, and for positive value it is different.
Yeah, right. And in slide, in a slide it had mentioned both the value are set.
Yes, it
So
is
that is
multiplied
wrong.
by 2.
Yeah, and it is multiplied by 2.
Okay, I don't know whichever. The thing is, some in a position like if we have a normal distribution, if you have so basically we have considered this portion and this portion as symmetrical. Yeah. So if you have the area of this portion, you also can multiply by 2 to get the area of this portion. In a sense, I don't know the question maybe. But yeah.
It's a
So basically, they, if I'm not wrong, they are talking about the measurement of proportion. I have also the same doubt actually.
I don't know actually, but
Because in that case,
Actually, one value is negative and one value is positive.
Because
right.
talking about the quotient,
Negative and positive are different values.
you're talking about the quotient related to measurement of proportion, or is there any other question?
It's a range related question. That is for week 6 only.
There we have calculate the Z value. No?
Yeah, Z value for the CL, confidence level.
Right. Sir, the Z value for negative and for the positive value we have calculated. Actually, it is coming out to be different.
Yeah, right.
Okay, so here the thing is,
Sir, actually, what happened? You had done equation wrong. Like you had you had done x bar minus range. So x bar value is greater than the range given.
Exactly,
That's why your answer is became positive. But actually, equation is that range minus x bar. That's why we are getting the negative value.
Sir, where in the numerator we have when we calculate the Z value, we have calculate the difference between the sample mean value to that of the population mean. But in that question, we have calculated the difference from that of the population mean. So what we have solved, we get the positive value. But here when we are going to solve, our values is coming out to be negative. For negative Z value, the calculated Z value when we see the confidence level is coming out to be different.
So in that case, what will be the range we can compute?
So yeah, if there is some error in that, maybe I maybe while doing it, so maybe I have.
Sir, may I have your
This type of question also are asked in the assignment, and there we get the solution, and same mistake is also there.
Yeah, same.
Okay.
Sir, here the value, the probability value is 0.3. If I'm not wrong, you guys are also talking the same thing. And P hat is 0.36. So P hat, when we're going to calculate the Z value, Then 0.3 is the sample mean. So 0.3 minus 0.36, it is coming out to be negative. But in the class, we calculated the sample mean, the population mean 0.36 minus 0.3. That is coming out to be positive there. The same question we have trying to solve the question number 3 also. Here also we are getting the negative value and your solution part is positive.
Okay, we can maybe see it. Yeah, I don't know. I have to see it.
Sir, can I have your email ID? So I will send you. And,
yeah. Sure. So.